Space, the endless darkness humanity has wondered about for thousands of years. A place so vast, so mysterious, that we often lose ourselves just by looking at it. But in this darkness, are we truly alone? In recent years, advanced space telescopes have revealed something astonishing. The universe is far more crowded than we once believed. Billions of galaxies, trillions of stars, and countless planets scattered across the cosmic ocean. But today, among this unimaginable number of worlds, one stands out. A planet observed by the James Webb Space Telescope. A planet with a 99.7% chance of hosting life. Its name, K218b. This could be the greatest discovery in human history. In the next hour, we will explore this planet, its discovery, the evidence, the controversies, and what it could mean for the future of humanity. If you're ready, let's begin.
James Webb is not just another telescope. It is the most advanced eye humanity has ever placed in space. Launched in 2021, Webb was designed to see the universe in infrared, a wavelength invisible to the human eye, but essential for studying the distant cosmos. Its 6.5-meter gold-coated mirror, its sensitivity to heat, and its location nearly 1.5 million kilometers from Earth allow it to collect the faintest light that has traveled across billions of years. Webb can see the birth of stars, the formation of galaxies, and the atmospheric fingerprints of distant planets. Why is this important? Because life leaves chemical traces that Webb can detect from unimaginable distances. And one day, Webb captured something extraordinary, a signal coming from a planet that wasn't supposed to be special, but it was. That planet was K2-18b. K2-18b orbits a small red dwarf star known as K2-18, located 120 light-years away in the constellation Leo. Red dwarfs are the most common type of stars in the universe. Small, cool, long-lived, but they have a double nature. On the one hand, their slow energy output creates a stable environment for billions of years, perfect for life to evolve. On the other hand, young red dwarfs can be violent, sending out bursts of radiation that could strip a planet's atmosphere. So when scientists discovered K2-18b orbiting such a star, the question became, could such a world truly support life? At first, it seemed unlikely. But then Webb looked deeper, and everything changed. K2-18b belongs to a newly identified category of planets called Hycean worlds. The word Hycean comes from hydrogen and ocean, describing a planet covered by a global ocean beneath a thick hydrogen-rich atmosphere. These worlds are larger than Earth, possibly 2 to 3 times its size, with deep oceans and temperatures that allow liquid water to exist. Liquid water, one of the key ingredients for life as we know it. What makes Hycean planets especially exciting is that they may be far more common than Earth-like planets. And if life can thrive in deep oceans, as it does near hydrothermal vents on Earth, then the universe may be filled with Hycean worlds teeming with alien biology. K2-18b might be the first proof of that possibility. When Webb analysed the starlight passing through K2-18b's atmosphere, scientists noticed something unusual. The atmosphere contained methane, CH4, carbon dioxide, CO2, water vapour. These were interesting, but not shocking. But then came the real surprise. A chemical signature that no one expected. Dimethyl sulfide, DMS. On Earth, there is only one known source of DMS: life. Specifically, tiny marine organisms known as plankton. The discovery sent shockwaves through the scientific community. Never before had DMS, or anything like it, been detected on an exoplanet. If confirmed, this could be the first direct evidence of extraterrestrial biology. Before the discovery of K2-18b's atmospheric signals, scientists had to answer a crucial question. How can we detect life from a planet we can't see directly? The answer lies in light. When a planet passes in front of its star, starlight filters through its atmosphere. Each molecule absorbs light in a unique pattern, a fingerprint in the spectrum. Methane, water vapour, carbon dioxide. Each leaves a clear signature, but detecting life requires more than just recognizing molecules. It requires interpreting how these molecules interact with each other. For example, on Earth, high methane plus low ammonia plus presence of DMS occurs only when life regulates the atmosphere. Webb did not just detect chemicals, it detected patterns that make sense only with biology. The question many people ask is, where does this 99.7% chance of life come from? The number is based on probability modelling. Statistical analysis of Webb's atmospheric data. Scientists evaluated two possibilities. 1. Non-biological processes. Could geological or chemical reactions produce this mix of gases? The conclusion, extremely unlikely. 2. Biological processes. Could microorganisms living in the ocean release methane and DMS, just as they do on Earth? The conclusion, this scenario fits the data almost perfectly. Thus, the 99.7% probability is not a claim that life is confirmed, but rather that life is the most likely explanation for the atmospheric chemistry we see. In science, that is a monumental statement. K2-18b is about 2.6 times larger than Earth and about 8 to 9 times more massive. This makes it a sub-Neptune, not a rocky planet like Earth. Its internal structure may include a thick hydrogen atmosphere, a massive deep ocean, high-pressure ice, a dense rocky core. If life exists there, it may be nothing like life on Earth. No continents, no skies, no sunlight reaching the ocean surface. Instead, life may thrive in warm, dark waters, perhaps near volcanic vents, powered not by sunlight, but by chemistry, just like Earth's earliest life. Even though K2-18b is tidally locked, meaning one side always faces its star, it may still have global storm systems, jet streams, atmospheric haze, ocean wave patterns driven by extreme winds. Hycean atmospheres behave differently than Earth-like ones. The hydrogen layer traps heat efficiently, creating a surprisingly stable climate. This stability could allow life to evolve and persist even in a world with no day-night cycle. The dark side of the planet might host icy cloud formations, while the star-facing side hosts thick steam and heavy clouds. These dynamic conditions could create complex chemical cycles and possibly biological cycles within the ocean below. The discovery of possible life on K2-18b changes everything. For centuries, humans believed Earth was unique, a lone oasis in an endless void. But if life can develop on a Hycean world, it means life could be everywhere. It means we may have been searching in the wrong places, looking only for Earth-like planets, when the universe may be filled with ocean worlds far more suitable for life. K2-18b forces us to rethink astrobiology, to rethink our place in the cosmos, to rethink the possibility that life is not rare, but common. And if life is common, then intelligent life might be as well. Of course, such a monumental discovery brings debate. Some scientists argue the DMS signal might be misinterpreted. Others believe the atmospheric model could be wrong. A few say natural processes might still explain the data. This skepticism is necessary, because science advances through challenge and questioning. But even the skeptics admit K2-18b presents the strongest evidence for extraterrestrial life ever detected. More data is needed. More observations are planned. But the excitement is real, and the questions are larger than ever. K2-18b is not the only planet suspected of hosting life, but it is currently the strongest candidate. Here's how it compares. TRAPPIST-1 system, multiple rocky planets, perfect temperatures but high radiation levels, no confirmed atmosphere yet. Proxima b, Earth-sized, very close, but extreme stellar flares may strip its atmosphere. Kepler 452, b, Earth-like orbit, older system, but possibly too hot now. K2-18, b, thick atmosphere, stable temperatures, potential globe-spanning ocean, strong atmospheric biosignatures. Among all known exoplanets, K2-18, b remains the only one with a strong, consistent chemical case for life. In the coming years, James Webb will continue studying K2-18b. Scientists hope to measure its ocean depth, map temperature layers, confirm molecular signatures, search for new biosignatures, understand its atmosphere more precisely. If any of these observations reveal stronger signs of life, it could become humanity's first confirmed alien world, a world where life exists beyond Earth. If scientists one day confirm microbial life on K2-18b, the consequences will be profound. It will mean life is not unique to Earth. Biology is a universal phenomenon. chemistry naturally leads to life under the right conditions. Humanity will rewrite science textbooks. Evolution is not a rare miracle, but a cosmic rule. Culturally, it will spark new religions, new philosophies, new scientific priorities, a new era where humanity sees itself as part of a living universe. And all of it will start with a molecule of DMS detected on a planet 120 light-years away. Maybe we are not alone after all. Maybe life has found a way, not just here, but on worlds far different from ours. And maybe, just maybe, K218b is the first whisper from the universe telling us that life is everywhere. Thank you for watching. For more discoveries about the cosmos, subscribe and join us as we continue exploring the mysteries of the universe.